This is Dr. Carroll, and this video is about object-oriented programming. Let's first talk about its predecessor, procedural programming, or PP. Software developers focus on writing procedures or functions. The functions then change the data. The programs are a collection of data and functions. This is action-oriented, and it's focused on the verbs in the problem specification. Let's see a diagram I created to help illustrate this. So here we have data, and it's going into function 1, and then it's being manipulated, it's changed, and now it's blue and bigger, and now it's going into function 2, and then it's now flattened and wider and changed color again to illustrate that the functions changed it. So here we have data flowing through functions and being changed. So we can use procedural programming when we're really trying to eke out all the speed that we can get. But there's two real limitations with procedural programming. One is that it's inflexible. A high-level change is likely to cause many modifications throughout your program. And two, it's difficult to reuse code or adapt existing code for different situations. So an example of a procedural programming language would be C. Now let's talk about object-oriented programming, or OOP. Object-oriented programming started in about the 1960s, but it didn't really become popular until about the mid-1980s. Software developers determined what objects are needed and how they work together. They focus on the nouns of the problem description as opposed to the verbs, which is a characteristic of procedural programming. Programs are then a collection of interacting objects, as the name suggests. Okay, let's see my animation here of how object programming would work. So the circle represents an object, which is a collection of both data and functions. And so here we have, we're now executing function 1, and it's changed the data. Now we're executing function 2, and it's changed the data still. And so the object holds the data and the functions, or we'll call them methods in a minute, to change the data. And so that's the paradigm change or difference between procedural programming and object-oriented programming. So now let's talk about what's an object. So they're an abstract concept. You can think of it like a blueprint. For example, a blueprint of a home is not a home, but it's the plans for a home. There's one blueprint, but it could make several homes from it. With objects, we can take the following steps. We can design them, then we instantiate them, and then we have them modify or work with the data. So we send a message to the object to operate on itself. Just like that illustration there, it had the data, and so we would tell the object by calling the functions there, and then it changed the data. So in general, object-oriented languages have data abstraction. They have inheritance, where one object inherits the characteristics of another. They have dynamic binding, or determining execution time, what type of object. So some examples of object-oriented languages are C++, Java, Python, Perl, and many, many others. Generally, programs model objects on real-world objects. For example, checking accounts, bank tellers, tickets, robot arms, robot legs, and the list just goes on and on. Object-oriented design is based on the philosophy that programs are easier to develop, test, and maintain when they are built around objects. To help solidify this, let's talk about some procedural programming versus object-oriented programming examples. So imagine that we have a program to keep track of time, so hours, minutes, seconds, AM, PM, that sort of thing. So a procedural programming approach passes around hour, minute, second variables to display time, to increment time, to set time, to many other functions. An object-oriented approach creates a watch object and then makes requests of that object. For example, watch.display, watch.increment, watch.set, etc. The object then stores the hour, minute, and second values internally. We're not quite sure how, but it stores those values and has the methods to work with those values. So let's talk about another example.
It's 3 o'clock.
A chess game example. So a procedural programming approach would make some chessboard and chessboard pieces. It would then make calls to functions to initialize the board, move the pieces, display the board, etc. An object-oriented program would make a chessboard object. That object would make game piece objects. Then the program would display the board by having the chessboard object have each of the game piece objects to display themselves. So it goes on. So now let's talk about the three main principles of object-oriented programming. There's many more, but these are generally considered the three main ones. They are encapsulation, inheritance, and polymorphism, also known as dynamic binding. So let's talk more about encapsulation. So this is where we put data and methods together in an object, like I just showed with that animation. So users only see the interface or the inputs and outputs, and thereby hiding the implementation details. This is critical to building large objects. You may not know this already, but the greatest cost of software development is maintenance. So well encapsulated components are generally easier to maintain. So let's talk about why encapsulation. There's many reasons for encapsulation. One is it creates modular programs. It allows code reuse. It provides data security. It supports team programming. It's easier to maintain and lowers software development costs. Are you ready Are you motivated now to encapsulate all your programs? Well, good. Let's talk more about inheritance. We're talking about hierarchical inheritance, not financial or genetic inheritances. For example, my Prius is a car, if you think about it in a hierarchy. And so it inherits all of the attributes of a car: price tag, mileage, year, etc. In code, we create a new type as an extension of an existing type, deriving a new class from existing class. That's what we do when we're coding with inheritance. So the derived classes inherit the attributes and behavior of the base class. This helps reuse existing code in an extensible manner. This is covered in another module. So now let's talk about the third principle, polymorphism. Polymorphism comes from the Greek, which means many forms. And what it is it's objects can determine appropriate method at execution time as opposed to at compiler time. So inheritance might make it impossible for the compiler to determine which method to execute. Polymorphism allows this determination to be delayed until runtime. So that's just a high-level introduction to it. It'll be covered in another module. That's it for this video. I hope you enjoyed it.